you're traveling with ice cream over a long distance, do you think it is a good idea to pack it with ice? No, there is always a danger of ice melting and water leaking out. Then how do you carry your favorite ice cream back home? Well, some solid substances such as dry ice do not easily melt down to liquid under normal atmospheric pressure. In fact, they change directly to the gas phase. So if you pack your ice cream with dry ice instead of ice to carry it over a long distance, you can travel without the fear of it leaking and spoiling your clothes. Such a process where a solid directly changes to vapor without going through its liquid state is called sublimation. Not only dry ice, but some other substances such as naphthalene and iodine also undergo sublimation. So now we've seen how solids can directly become gases. Is the reverse of this possible? Yes, it is possible. At times, in very cold weather conditions, we find water vapor directly converting to solid ice. This conversion of gas to solid form is called deposition. And it is the reverse of the process we just saw, sublimation. So far, in all the processes like sublimation, melting and vaporization, we have seen how temperature affects the state of matter at a constant atmospheric pressure. Now, let's understand how changes in pressure influence the state of matter. Have you seen LPG cylinders being used at home? They are mostly used for cooking food. Are the contents of the cylinder gas or liquid? LPG, as the name suggests, exists in the liquefied form. Since gases are not very easy to contain and are highly combustible, it makes sense to liquefy them. Scientists figured that if we apply high pressure to gases, we can bring gas particles closer to each other and condense them into liquids. This shows that gases are compressible, right? Now, when gases are compressed, it becomes more convenient to store and transport them. Imagine if we try doing the same to a solid or a liquid. Would that change their state too? No. In fact, applying pressure would hardly have any effect on solids and liquids. Don't believe me? Okay, let me show you with an example. Here I have a tub of water with me. If I try pushing a wooden plank in it, water just splashes out. But does it change its state? No. Water is still a liquid. What about the plank of wood? Does that change its shape? Of course not. It's still in the solid state. So this means that compared to gases, pressure has very little effect on both liquids and solids. This is mainly because particles in solids and liquids are already placed close to one another. It is extremely difficult to bring such particles any closer just by applying pressure. So at this point, we can say that solids can change into liquids by melting and into gases by sublimation. On the other hand, liquids can change into solids by freezing and into gases by evaporation. Thus, solids and liquids are mainly affected by change in temperature. On the other hand, gases can change into solids by deposition and into liquids by condensation. Along with this, gases can also change into liquids by application of high pressure. Thus, gases are affected by both changes in temperature and pressure. This brings us to the end of our session. Let's go through the key points again. The change of a substance from its solid state to its gaseous state is called sublimation. In this process, the substance does not go through the liquid state. The opposite of sublimation is called deposition, where a gas gets converted to a solid. Change in state of solids and liquids are mainly controlled by temperature. there is very little effect of pressure on solids and liquids. Gases can also change their state to liquid under the effect of high pressure. So I hope now you understand the importance of pressure and temperature in changing the state of a substance. But do they always work together, or are they independent of one another? You will learn more about this in higher classes. Keep learning, and I'll see you soon.